In part 3 of this series, we're asked to derive the following 4 functions. But unlike in part 1 and part 2 where we actually had to derive the following, this time I'll use these templates to come up with the solutions faster and easier. Let's start with part A. In part A, we'll be using the following relationship. So I'll first set part of my expression as u. I'll set this part 3x as u. U is equal to 3x. And according to this, we have to find the derivative of u with respect to x. So let's find the derivative of u. Du over dx is equal to 3. Next, I will write down y prime is equal to 1 over the square root of 1 minus my u, which is 3x. That becomes 9x squared times 3. And feel free to put that 3 up there. That's it. That's the answer for A. Now for B. This time for B, I'll set this part as my u, and that will require some space to derive. U is equal to the square root, or 1 minus x to the power of half. This and this mean the exact same thing mathematically. Taking the derivative of this, I'll bring half to the front. I'm using the chain rule here, so I need to find the derivative of this as well. Subtract this by 1, that gives us negative half. The derivative of that is negative 1. And don't forget that these are being multiplied. So we end up with negative 1 over 2 times the square root of 1 minus x. By making this positive, it has to be flipped to the bottom, and I switched it back to radical form. Now what I'll do is use this relationship, I already found that, and multiply it to the following, where I get y prime is equal to negative 1 over negative 1 square root of 1 minus my u to the power of 2. My u was this. Squaring a square root gets rid of the square root. So we have 1 minus x. And I can clean this up right now. 1 minus 1 minus x. That's like saying 1 minus 1 plus x. This and this go away, so we're left with simply the square root of x underneath times what we found earlier. This negative 1 and this negative 1 will multiply. That gives us positive 1 over, and here, remember, this is the square root of x. We have a 2, the square root of x times the square root of 1 minus x. These two can be combined, and I'll do that over here. X times 1 minus x gives us x minus x squared, and our final answer is 1 over 2 times the square root of x minus x squared. And don't forget the prime symbol. Let's quickly do C and D as well. This will be my u. U is equal to, the derivative of 1 is 0, the derivative of 2x is simply 2. And I'll write down du over dx. Similarly, for this, we have u is equal to x squared plus 1. This becomes du over dx is equal to 2x. And we found this and that. Let's go ahead and fill this in. For C, starting with y prime is equal to 1 over 1 plus, my u here is 1 plus 2x. 1 plus 2x, make sure that you put it in brackets, times my derivative of 2, where we end up with 2 over 1 plus, and there's no need to expand this, 1 plus 2x squared. In D, we have y prime is equal to negative 1 over 1 plus u to the power of 2. My u was x squared plus 1. X squared plus 1 to the power of 2 times 2x. Times 2x. Leaving us with our final answer of 2x over, and there should be a minus here, 1 plus x squared plus 1 squared. And so there you have it. 4 examples on how to find the derivative of inverse trigonometric functions.